another lecture of quantum mechanics. In last lecture, we discussed about wave function, and continuing this lecture, we'll discuss about normalization. Okay, so in sometimes it's written as normalization instead of Z, there is a S also. Okay, so what it is? So let's define it. Like if we know that the probability density is psi square dx, if we integrate this quantity, okay, over all space, okay, so what happens is if we get 0, all right, if we try to find out the total probability by integrating over this density, as we had seen in probability lectures, okay, so if it comes out to be 0, the particle doesn't, it means that the particle does not exist anywhere, does not exist anywhere. If you have difficulty in understanding probability, please look at the lecture on probability which I have given in like other earlier lectures. Okay, so if it gives you a brief account of the probability definition as well as the distribution function. Okay, so for the particle to be present somewhere, kahin to hoga, right? It has to be somewhere. If the system has this particle, one particle say, it has to be somewhere, right? So if you for the particle to be somewhere, or if the let's write it, if the particle is somewhere, is present somewhere, right? It has to be somewhere, right? So if you integrate over all space, okay, we are using one integration because it's a 1D system we are considering. Okay, for 3D system we'll have 3 integrals. Okay, and this would be 1, right? Now this condition, this equation is the normalization condition. Normalization condition. Okay, so now let's label this to be 1. Now it says that if a wave function satisfies this condition, if a wave function satisfies this equation 1, then it is said to be normalized. Okay, so this is the condition which the wave function should satisfy, which is psi mod square integration over whole space should give you 1. Now we'll understand why this is required. Okay, what is normalization? What do you mean by normalization? Okay, so let us consider a biased die. Now what does biased mean? What is unbiased? If you have been a student of probability, if you learn probability, what is a unbiased die? Unbiased die is something which all sides, occurrence of all sides have equal probability. Okay, actually it means that the mass distribution, physically it means the mass distribution is uniform. Means all sides are equally probable, okay, in the outcome. But when you have a biased die, okay, that means the mass distribution is not uniform. means one side or one few more sides will have more probability, like higher probability of getting the occurrence will be higher. Okay, the probability of the occurrence will be higher. So mass distribution is non-uniform. Okay, so let's use this thing. Let's use the biased die. Biased die, in unbiased die, the probability of getting, say, let's represent this thing. Let's use a notation. Probability of getting some number on the die. Die has how many numbers? So you have 6 sides, so 6 numbers, 1, 2, 3, 4, 5, 6. Okay, so this is we represent by pi, probability of getting I. Okay, so in biased die, what will have, this distribution will be like biased dies will, the distribution will be like that. Probability of getting 1 will be 1 by 6, probability of getting 2 will be 1 by 6, so on. Like probability of all will be, you're getting any number, like all the numbers will be equal. Okay, equally probable. But in biased die, sorry, this is unbiased die. Now if you look at biased die where the mass distribution is unequal, let us like the let us like assume that the probability is like this. Okay, now probability of getting 2, let it be 0.15, probability of 3, let it be 0.05, and probability of getting 4, let it be 0.25, probability of getting 5, let it be 0.20, probability of getting 6, let it be 0.20. Okay, now probability of getting any number, it will be a summation of all of these. Okay, so you'll get 1. Just check it. Okay, see, always pause the video and try for yourself. All right, then only you'll learn. Now if instead of this number, if I write that probability of getting 1 is 15, probability of getting 2 is 15, probability of getting 3 is 5, probability of getting 4 is 25, probability of getting 5 is 20, probability of getting 6 is 20. Now see one thing, that this looks different, right? This was point, it's the same dice, but I am writing it like this. Okay, you can observe one thing, that I multiply 100 to this, I multiply 100 to this. Okay, so the relative probability of this is what? 1. Relative probability means if you divide this by this, you'll get 1. You'll divide this by this, you'll get 1. So and if you divide this by this, you get 3. If you divide this by this, you get 3. So relative probability remains the same. Let me write down relative probability in this case. How should I write down? Let's put it here. So relative probability remains same. Remains same. Okay, so what changes actually? So if you add them up, if you add all the probabilities, okay, so what do you get? You get 100. Now we want that the total probability of getting any number in this die should be 1. So what we need to do? We need to divide this quantity, each of them, by what? By the sum of all the probabilities. And this process of dividing by this number, okay, so that you can get this summation of these probabilities to be 1, is called, this process is called the normalization process. Okay, so what we did was, we had this normalization condition because it has to be true. Because the probability of any getting any number should lie between, the probability of getting any number should lie between 0 and 1. Okay, so to get these numbers for any kind of probability, like even in this one also, this quantity should be 1. Okay, this quantity should be 1. All right, But if you're not getting it to be 1, it says one, instead of 1 it's 10 or 2 or 3, whatever it is, we can always normalize it. If you find these lectures useful, then please like, subscribe, and share with your friends.